Good evening, ladies and gentlemen. And I use the word lady respectively because there is one in the back row. Welcome to Engineers Ireland and our evening lecture this evening that's hosted by the Civil Division of Engineers Ireland. And some of you might argue, well, why the Civil Division doing this rather than the structures or the actual contracting division? Well, one of the simple answers is that the Civil Division took on the challenge of getting involved with the Department of Environment on the new B-car regulation. So by default, or for our sins, we thought we should take on this one as well. As you can imagine, there are a number of safety announcements to be made. In the case of fire, which has never ever happened here, but of course you can never eliminate the possibility. Emergency exits are to my left in the corner, and the door through which you came, and the congregation point in the case of that of an emergency evacuation is on the pavement outside the front of the building. If you have a mobile phone on you, can you please make sure it's either turned off or turned to mute or vibrate or whatever is necessary to make sure it's not a distraction. Later on, at the conclusion of the lecture, we will have a Q&A session. I would ask that you tell us who you are and when you're asking your question, because tonight's proceedings are being webcast. So on that regard, in that regard, I'd like to welcome those who are on the webcast. You may not be with us in person, but you're with us virtually or in spirit or whatever the appropriate terminology is. In terms of the flyer that was put out for the lecture, what I tried to get across was the fact that this is not a lecture about how we've got to where we are in terms of building control regulations. There's been enough hot air expended on that one. This is an actual application of one of the consequences of the building control regulations. So this is a specialist subject, and in that respect, I'm delighted to welcome our speaker this evening, who's Chris Dilworth. Chris has specific responsibility for the acoustics team in AWN Consulting, who are Ireland's largest and most experienced acoustic consultancy practice. Chris is a European engineer and a chartered engineer with BEng in electroacoustics from the Department of Applied Acoustics at the University of Salford. He is a corporate member of Engineers Ireland and the Institute of Acoustics with over 30 years' experience in the field of acoustics, and he has been a consultant since 1989. So ladies and gentlemen, would you please welcome Mr. Chris Dilworth.
Thank you very much. Good evening, everyone. So tonight's presentation focuses on aspects of the building regulations relating to sound. In particular, what the regulations have to say for themselves. We have a brand new set of regulations in force from the 1st of July this year. How to demonstrate compliance, and we'll talk about some of the implications and some of the requirements for the competencies of the people involved in testing and assessing constructions. So first of all, I'll just bring up the regulations themselves. Each wall and floor separating a dwelling from another dwelling or dwellings, other parts of the same building and adjoining buildings shall be designed and constructed in such a way so as to provide reasonable resistance to sound. So we're talking about separating constructions. We're not talking about constructions within the dwelling. We are talking about separating constructions between dwellings and between dwellings and other buildings. Now, the scope of the regulations, in truth, is quite limited in this regard. During the preparation of the amended regulations, there was some debate as to whether or not they should be expanded to encompass things like hospitals, schools, long-term residential accommodation like nursing homes and student accommodation. But the decision was taken that there are existing provisions in that respect dealing with those other applications, so there was really no need to widen the scope of the regulations. It's kind of an arguable point, and I would be hopeful that future revisions will bring in some of those other areas. Anyway, for the moment, we're looking at long-term we're looking at dwellings only. The requirement itself for reasonable resistance is defined in the regulations. It's defined by way of a performance standard, and that's the single biggest difference between the new regulations and what we had up to this point. Prior to now, reasonable resistance had no concrete definition. So there was a certain element of subjectivity to it. There were de facto performance standards typically applied, but no absolute limit values or guidance within the regulations themselves. So that's a big change. We now have a mandatory performance standard. We also have a brand new regulation. The common internal part of a building which provides direct access to a dwelling shall be designed and constructed so as to limit reverberation in the common part to a reasonable level. Now that's really talking about entrance halls and stairways, corridors, giving direct access to multi-occupancy dwellings. So apartments opening off some kind of common circulation area. The idea being to keep reverberant noise build-up down to a reasonable standard to prevent that noise then breaking through and transferring into the apartment. That's a brand new regulation, and again there is some concrete guidance as to how it's to be applied. So that term reasonable resistance, we now have an absolute performance requirement, and they're set out in Table 1 in the technical guidance document that accompanies the regulations for Part E. And I've reproduced Table 1 there. Now, we're looking at sound insulation in respect of both airborne sound and impact sound. So airborne sound is the sound of a voice, television, anything that travels through the air across the separating construction into the apartment next door or the dwelling next door or the apartment below. So that's airborne sound. Impact sound is primarily footfall noise. It's only applicable to floors, and it's the noise of people walking around or moving furniture or dropping things. Now the way in which these performance standards are set differs. We use two different indicators. For airborne sound we use an indicator DNTW, weighted standardized level difference. And that's just basically a measure of the degree to which the separating construction reduces the transfer of noise from one side of the partition to the other side. So in terms of airborne sound, the higher the better. And the requirement is 53 decibels for both walls and floors. Impact sound, on the other hand, is measured in a different way. When we measure and assess impact sound, we measure it using a thing called a tapping machine, which is an instrument that we set down on the floor. It lifts and drops a series of hammers, and it basically generates a known level of energy within the floor, and we then measure how much noise is created down below. So obviously the more energy that's created down below, the louder it is, the worse the floor is performing. So in terms of impact sound, the higher the number, the worse. So airborne sound, the higher the better. Impact sound, the lower the better, because it means we're generating less noise for any given footfall in the room below. That's all brand new guidance. So Part E, the technical guidance document, contains details of what they term acceptable construction. Section 3, separating walls and flanking details. Section 4 talks about separating floors and flanking details. And basically what the regulations are saying is, if you design and construct your separating constructions in accordance with those details, you are in essence in prima facie compliance. But the difference between the current regulations and the old regulations, where that was enough, is that you still have to test the construction. Because what they're saying now is that you're in prima facie compliance in terms of the design, but now you need to go to site and measure the performance in situ prior to completion to make sure that workmanship is of the appropriate standard and that site conditions are fully accounted for. So we can build using these acceptable constructions, but we still have to test them. The advantage being, if we build using these standard constructions, you can conduct fewer tests in order to demonstrate that they're achieving the appropriate level of performance. So that's just an example of the guidance from the regulations. There are details for the constructions generally, specifications for materials, confirm minimum requirements in respect of things like surface mass, performance of resilient materials that you may be laying down to cut down on impact noise transfer. And then there are details relating to flanking noise transfer and the control of noise coming through voids and at junctions and pipe penetrations. There's a lot more information in Part E in the technical guidance document than there used to be. Quite comprehensive in respect of the standard acceptable constructions. Testing is a big part of the new regulations, and it's something we've been lobbying for a long time, because in essence the old regulations relating to sound were pretty toothless. You had no absolute performance requirement that was mandatory. There was no statutory or mandatory requirement for testing. So generally you find you were only doing a test where, more often than not, where there was a problem, and you were doing a test in order to find out what the problem was and tell them what they had to do to fix it. But testing is now mandatory. It needs to be conducted prior to completion, and it needs to be undertaken by a competent person. Now I'll come back to that, and I will dwell on that later, because the regulations are extremely hot on competence. And there are a few reasons for that, and I'll talk about that in a little while. So in essence, you want to undertake tests on a representative sample of your dwellings. So you need to look at the different unit types, you need to look at the different layouts, and in particular the different constructions, and develop a testing program that takes into account all of those and gives you a good cross-section across all of the various different constructions and unit layouts. Now I've said here other construction types require more tests. So in other words, an other construction type in the context of the regulations is one that isn't set out in Technical Guidance Document E. So if you're using one of those non-standard constructions, you need to do additional testing. However, there is a way of avoiding that, which is known as the assessed sound detail. I'll talk about that in a minute as well. So the testing is all brand new. So the concept behind the testing is of a set of tests. In houses or bungalows, in other words, where there are no separating floors, a set of tests comprises 2 airborne tests on walls. In apartments and duplexes, however, where we do have separating floors, a set of tests is 2 airborne on walls, 2 airborne on floors, and 2 impact on floors. So 3 times as many tests. And testing in apartments does take a lot longer than it does in more traditional houses and bungalows. So the frequency of testing. So we've got this concept of the set of tests, and the technical guidance document tells us how many sets of tests we need to do for any given development. So first of all, there's a table 3A, dealing with the TGD construction. So these are the standard acceptable constructions set out in the technical guidance document. And you can see there, hopefully you can read that okay, you can see that it's a function of the number of attached dwellings. So if you've 4 or less attached dwellings, you need to do at least 1 set of tests. If you're greater than 40, but less than or equal to 100, it's at least 4 sets, and 5% times the number of attached dwellings greater than 40. So a fairly simple approach. You basically say, right, I've got this number of dwellings, how many sets of tests do I need to do? And then depending upon the dwelling type, you know how many individual tests there are in each set. If you have different construction types on the same site, you need to repeat this process for each different construction type. So if you're separating wall, if you're using 2 different types of separating wall, and let's say you have 80 houses on the site, 40 of them are built using one wall type and 40 using another, you have to go to this table once for the first construction type and 40 dwellings, and you go to it a second time for the second construction type and the remaining 40 dwellings. Then we are given the frequency of testing for other constructions, and there are additional tests. So if we take an example, if we go into the greater than 20 but less than or equal to 40 bracket, they're saying at least 2 tests plus 10% times the number of attached dwellings greater than 20 for a standard construction type. And then they're saying at least 6 tests plus 10%. So an extra 4 sets of tests. So in particular for apartments, using a non-standard construction type can lead to quite a lot of extra tests. Now, in truth, even though there's a lot of information in TTDE about the standard constructions, they're quite prescriptive, so it's very easy to find yourself in a situation where you're using another construction. Most of the sites we're working on at the moment are using other constructions, so they need to use the increased frequency of testing. So the assessed sound detail, when the regulations were being drafted, originally the department wanted every single example of a separating construction tested if it wasn't a standard detail. Every single separating partition. Now, that would have had massive implications in terms of programming, testing on site, and cost. And it was argued at the time that it was also anti-innovation, because basically if you were coming up with a construction detail that was offering additional performance, enhanced acoustic performance over and above the minimum in the regulations, you're actually being penalised, because they're saying, no, you need to do lots of extra tests. We don't care how good it is. So after some debate, they rode back on that, which is how we have these two regimes for deciding how many tests to conduct. But it was still felt that it was a little unfair that if, let's say, a contractor has a preferred detail, they use it every time, they may be using it for hundreds and hundreds of houses, why should they have to use that enhanced frequency of testing? And the department said, okay, I came up with a new scheme called the assessed sound detail. So basically, if you have a construction that you want to reuse again and again, you get it tested on 2 different sites by 2 different test bodies, and you test 30 examples of the construction, and assuming that they all come up to scratch in terms of the performance standard, you can have that submitted to a third party for certification, and that construction becomes an assessed sound detail and is subject to the same reduced frequency of testing that applies to one of the standard details in the regs. So in other words, it's a way of getting some other construction handled in the same way as if it was a standard detail. So procedure for testing and reporting, conducted by a competent person in accordance with a variety of standards. The standards have actually changed since the previous regulations, so they're a lot more onerous. The requirements for the testing procedure are a lot more involved. Tests ideally should only be conducted between living rooms and bedrooms where possible. You can use other spaces where necessary. Toilets, really, we don't use them at all. The rooms are too small to give meaningful results. They're typically tiled, and there are various other aspects that mean that they're not suitable for test. And again, provided the apartment layout permits it, rooms should have a minimum volume of 25 cubic meters for testing. So we test in completed but unfurnished rooms. So these are pre-completion tests. But that really means, I suppose pre-handover might be a better expression, because we need everything to be complete. All doors on, handles on, skirting boards, vents, trickle vents, windows, everything needs to be complete. Otherwise you're not testing a representative example of the construction. Closed doors and windows. If you're testing a wall that has fitted units on it, you need to make sure all the doors are open and nothing in the cupboards. There are rules in terms of where you place your sound source. I'll tell you in a moment what that means. 2 individual tests on any given separating floor. Now what that means is not the same example of the separating partition, but it might mean you have a separating wall between two houses. You can test a bedroom upstairs and a living room downstairs. That's really what we're saying. If you test and you fail, and it's deemed a failure if any example of the construction fails to meet the minimum performance requirements given in the regulations. So it used to be Although we didn't have mandatory requirements previously, there was what was called a similar construction test method in the previous regulations that allowed you to test a construction. If it came up to a certain standard, it was deemed good enough to be reused on another site. Now, the levels attached to that became the de facto standard, but they were based on a mean, so you could test 4 or more constructions and take an average performance. And provided the average performance achieved a certain standard, and there was no individual construction that fell below another certain standard, that was deemed to be a satisfactory level of performance. That's completely gone. There's no issue, there's no concept of means in the testing anymore. It's a single absolute value. So if you fail to meet that single absolute value, your tests are deemed to be a failure. You've got to remediate the failed constructions and retest until you demonstrate performance satisfactory. And then you need to prove that you can obtain the same performance from all the other constructions. So if you've already tested a batch of constructions that seem to pass, you have to go back and retest, or you have to apply those remedial measures retrospectively to those constructions as well. And the other outcome is that you have to increase the frequency of testing. So for the remainder of activity on that site, you need to do additional tests. A failure really is bad news. You shouldn't be failing once you've got to this stage. So the amended Part E was published in December 2014, and the guidance therein, and in particular the detailed guidance in relation to testing, applies to any site where the works or the change of use commences or takes place on or after the 1st of July 2015. So it's only for sites where work has started on or after the 1st of July 2015 where these mandatory testing requirements apply. So even though we're regularly testing sites, none have yet been tested where there's a mandatory requirement, because they're just not that far on. The first ones will probably come up towards the end of this year, early next year. So they'll be the first ones under the new regulations. So we're going to step back a little bit in terms of how we can ensure good sound insulation, because I've just said by the time you get on site and you're testing, you shouldn't get a failure. And there are lots of ways of making sure that that's the case, that you don't get a failure. Use construction types that work well. Make recourse to existing test data. Or, if you've got a construction for which you don't have much existing data, a robust theoretical assessment. And we have lots of tools that help us with doing theoretical assessments of the sound insulation performance of constructions. This is a piece of software called Insul, where we can model separated constructions. It allows us to model 3 separate panels, frames, connecting members in between. You can change the insulation that may be in the cavity, change thicknesses, masses, and it's quite accurate. As accurate as any tool like this can be, but you really need to understand the output in order to be able to interpret it properly. Because what it does give you is a theoretical laboratory performance. So you've got to understand how that laboratory performance translates to in-situ performance. Now, one of the ways we can do that is we can use a tool called Bastian. And Bastian basically allows you to model pairs of rooms, and you can model all of the constructions, linings, room finishes, and then assess noise transfer between a source and receiver. So that little green object represents the source in one room, and we assess how noise travels from that room into the adjoining space. Now the thing about a Bastian that's so useful is it tells us exactly how the energy is traveling from the source into the receiver. So it tells us how much noise is going across the separating wall. It tells us how much is flanking through the ceiling, through the floor, through penetrations, window openings. So it means that if you do, when you're undertaking your assessment, identify some kind of shortfall, it'll allow you to focus in very quickly on exactly where that shortfall is arising, what's responsible for it, and you can then perhaps target a wall lining or something at the surface that needs it. We use another tool called Sound Architect, which, if you like, is a much more detailed version of Bastian. It allows us to assess much larger buildings. And basically you model all of the key constructions in a manner that's meaningful in terms of acoustic performance. So you don't need to worry too much about detail in every nook and cranny. It's basically overall surface areas, the separating planes between rooms that you need to model. Then you can assign construction types to them. That's what we've done on that drawing. The different colours represent different partition types with differing levels of performance. Then you attach a usage to all of the rooms, and you can then define all of those rooms' acoustic characteristics in terms of the performance you want to achieve. And then Sun Architect, embarrassingly quickly, will do tens of thousands of calculations for you to work out how noise is travelling around the building. So the example I've been showing you here is a wing from a new hospital. The procedure is the same irrespective of the building type. And what's great about it is it enables you to very quickly identify where you may have a problem, where your separated constructions aren't coming up to the required performance standard. And here you can see in that example, it's showing me a pair of rooms where there's an issue. It's saying, okay, sound insulation performance is up to scratch. So in truth, the way we would assess the performance is a combination of all three of those tools. We would say, okay, this is the construction we want to use. Tell me what its performance is. Now I'll look at it in 3 dimensions and all of the interfaces, and now I'll look at how it behaves in the building as a whole. We also need to detail junctions carefully. More often than not, when there is an issue with residual sound insulation performance, it's down to some poor detailing. Junctions and penetrations being particular culprits. Consider the potential for noise transfer via flanking paths. So that little diagram just illustrates that the noise is going to travel. There's one path across the separating construction, which we call the direct sound. And then there are many, many paths for flanking sound. So we need to make sure we consider that. If we've used those detailed tools like Bastian and Sun Architect, those are ways of including a flanking assessment in your overall assessment. Inspect during construction. Once you've got the design right, you need to make sure it's being built properly. Again, acoustics can fall down on little details. Poor ceiling, gaps around a socket box, gaps where the partition comes up to meet the soffit, that kind of thing you need to try and catch during construction. Conduct pre-completion testing, which is now mandatory. If necessary, make recourse to a variety of noise control measures. We know a lot about how constructions perform. We know a lot about how to fix them if they underperform. We don't want to be there. The rule of thumb that we apply is if we're remediating a construction for acoustics, it will cost between 10 and 20 times as much as if we got it right in the first instance. So that's sound insulation. I'm going to move on to reverberation control for a few minutes. This, as I say, is brand new guidance. We're talking about controlling noise build-up in common circulation space in multi-unit dwellings. And the regulations give us 2 methods that we can follow to decide how much absorption is needed and where to put it and what it should constitute. And this is all brand new guidance. There was nothing about reverberation control in the previous editions of the building regulations. So the guidance is based on the concept known as absorption class from A to E. Now, absorption basically describes the ability of any material to absorb sound that strikes it. And we use an indicator known as absorption coefficient to express that. If something has an absorption coefficient of 0, it will reflect all the sound that hits it. And if it has an absorption coefficient of 1, it will absorb all the sound that hits it. Most materials are somewhere in between. So we can classify the absorption coefficient, the absorption of any material by looking at its overall performance. And we look at it across the entire audible frequency spectrum as well. So you can see there, class A absorber is the best. So in other words, a class A absorber's absorption coefficient performance is in the blue sector right across the frequency spectrum. And then we get Class B, Class C, D, E. A being the best, B being the worst. So our first method is one that we can apply to entrance halls, corridors, and hallways. And we apply an acoustically absorbent material to an area equal to or greater than the floor area. And it needs to be a Class C or better absorbent. It's quite a simple approach. Stairwells or a stair enclosure, we have to calculate a combined area of a few different surfaces, stair treads, landings, top floor ceiling area, and so forth. And then we introduce an amount of absorption equivalent to that area, if it's Class C. Sorry, that should say Class D. Or 50% of that area with a Class C absorber. So in other words, if you come up with 100 square meters of treatment required for Class D, you can use 50 square meters of Class C because it has more absorption, so a smaller area will do the same job. Method B is a different approach. Method A, you could see, is quite straightforward. It's simply calculation. You take your drawings, you work out some areas, and you go, okay, I need a Class C or Class D absorber, and I'm going to put it in here. Method B, in essence, you look at the amount of absorption that's being provided by the proposed basic schedule of finishes, and you look at a performance standard for the particular space, and you calculate the additional performance, the additional amount of absorption that's going to be required. And although that's a more laborious process, the advantage is that it typically results in requirement for less absorption. So method A, in other words, is a bit conservative. Method B, if we go to the lengths of calculating and assessing, we can use a bit less absorption. So there's an example in the TTDE. There's your construction. You look at all your different surfaces and its absorptive characteristics. There's a calculation template, and that particular example says that if you follow this process, you can use a Class D absorber instead of Class C. So you can use a cheaper product. Alternatively, you could stick with a Class C absorber and use a smaller coverage area. So it's primarily a way of saving costs. Okay, so look, that's the discussion of the regulations and the requirements, and some outline guidance as to how we can go about complying with them. Now I want to talk to you about the certification scheme that has been established in order to cover people who are undertaking the testing work. It was the department that decided that this new regime needed some kind of certification scheme. They talk about it in TGDE. Sound insulation tests carried out by a person certified by an independent third party to carry out this work offers a way of ensuring that such certification can be relied upon. So there are two real reasons why the department wanted to go down this particular route. One was to make sure that there would be an adequate supply of suitably competent and properly trained assessors, and the other was to try and make sure that anyone undertaking these tests was up to the job, that they had the requisite knowledge, instrumentation and commitment to do it properly. Now, by implication, you might infer from that there were people that they considered weren't up to the job, and I think that's a fair point as well. In the absence of any kind of certification scheme, we have had some people, for want of a better expression, dabbling, and we've seen some pretty ropey results coming back and some pretty poor quality testing. So we want to try and stamp that out. So the department were really looking for an industry-led scheme, so they basically extended the invitation out to a few of us that were members of the working group that helped with Part E and said, what can you come up with? So we now have a scheme called SITRI, which stands for the Sound Insulation Testing Register Ireland. So I want to talk about that for a few minutes, just before finishing up, because it is very much an integral part of the new approach to sound insulation. So the certification scheme, it's been developed by the Association of Noise Consultants and the Institute of Acoustics. It's a not-for-profit professional body, and it's modelled on an existing certification scheme in the UK. So the two people behind it, the IOA is the UK's professional body for those working in acoustics, noise and vibration, and we have a very active Irish branch. There's no Irish equivalent. We have the IOA. It kind of fulfills that need. The Association of Noise Consultants is a trade association for acoustics, noise and vibration consultancy practices. So I suppose the difference between the ANC and the IOA is that the ANC is very much an organisation targeted at consultants, whereas the IOA is a broader umbrella organisation for all kinds of people with an interest or in acoustics or working in the field of acoustics. So it's quite a comprehensive application process, and I want to go through it not in detail, just to give you a feel for what's involved so that you can see exactly the level of detail that's required in order to ensure that somebody's capable of conducting these tests. So anybody that wants to become a tester, become certified for doing sound tests, needs to make an expression of interest. They do that through the website. They get a guide to the application process and they get a scheme handbook. They can then go through one of three routes to registration. One is training. Now, one of the department's key objectives was to make sure that nobody would be excluded from the scheme if they had a willingness to undertake the necessary training and make the necessary commitment in terms of time and instrumentation and money. So there is a route then that anybody who wishes to become a certified tester, who need not have any previous experience of acoustics, can become a certified tester. So they go through the training route. For existing acousticians, they will typically go through the review route, which involves considering their qualifications and experience. And finally, there's a third route for anybody that has an existing accreditation from another jurisdiction, say UCAS in the UK. It's a slightly more straightforward process for them. So training or experience, basically the first thing somebody says is, okay, do I meet all of these requirements for people joining the certification scheme? So there are some non-technical conditions: employment, PPE, site procedure, etc., etc. And then there are technical conditions: acoustic theory, familiarity with the standards, IT skills, instrumentation, and a membership of the IOA or equivalent. So if you're already able to tick the box beside all of those, you go the experience route. If you can't, you go the training route. So a review of qualifications and experience is fairly much as it sounds. They want to know that you really can undertake these tests and you have the right kind of experience. The training, on the other hand, is based around a course called CCI-BAM, the Certificate of Competence in Irish Building Acoustics Measurement. It's a 5-day taught course. It's based on an existing course in the IOA, and it involves practical and written examinations on the 5th day. And once you complete that course, you can move on to the registration audit. And everybody, whether they go by the experience route, the training route, or the existing accreditation route, will wind up with the registration audit, where a scheme examiner looks at all of your procedures, and you can see at the bottom the kind of things they're interested in: equipment maintenance, method statements, terms and conditions, quality control. They will also review a typical report with all of the calculations therein for a test that you've conducted, and they'll also witness a live test. So it's a thorough process. And when you, assuming somebody gets through that process, they're added to the register. So that register is basically a repository of names and details of people who are certified to undertake these sound tests. So that anyone who needs to find a competent tester, say an assigned certifier, a client, an architect, building control, want to make a recommendation, they can go to the register and get the name of somebody who can undertake these tests. The members themselves have to stick rigidly to the application of the various standards and the scheme handbook. They need to upload results to the scheme database, undergo an annual audit, undergo witness tests. If you don't do it, there will be sanctions and you may be removed from the register. Now, one of the reasons I've gone through this in so much detail is because of the importance that the new regulations place on competence and the importance that the department itself places on competence. So this is one mechanism for demonstrating that somebody is able to conduct these tests, that you've got a certified tester. I want to be absolutely clear, though, that it's not a mandatory requirement. A tester does not have to be a member of CITRI, but they have to be able to demonstrate all of this expertise by some other route. Now, there's no other formal route in the country by which they can do that at the moment. So, for example, an assigned certifier would have to satisfy himself or herself that the tester is ticking all of those boxes. All the same boxes that CITRI is assessing when it certifies someone. Now, the final part of the CITRI scheme is what's known as VISIT, Verifying Irish Sound Insulation Tests, and it is a database of the results that will be accessible to building control, assigned certifiers, clients, architects, etc. So you're a certified tester will have a unique password and a site identifier. It's all anonymous that he will be able to give out to, let's say, the assigned certifier, who can go to this website and download a summary report. And that will be permanently maintained on record as well. Now, there's a more formal report as well, but it's big. There's a lot of technobabble in it. The summary report is a very useful way of summarizing the results from a particular site. Not only that, it summarizes the history of a particular site. Because if there's a failure, the failure will also be up on the VISIT website. And then the history of the increased frequency of testing and the additional testing and remediation will all be down there in that summary report as well. So the timescale for the scheme itself, new regulations came in on the 1st of July. They were launched at a workshop for building control on the 9th. The scheme's website went live at the end of July. The first presentation of that training course that had 8 people on it went live on the 31st of August. CITRI had its first set of registration audits last week, and it has the second set on the 23rd of November. So as of this month, there will be certified testers going on the register. And hopefully there'll be about 20 testers on the register by the end. And that's really it. I think we've done all right for time, I think. Just about. Yeah. No, you most definitely can. 58, the first thing is the airborne sound, the 53, is kind of meaningful because any consultant who's testing these constructions will know how well a construction performs based on its airborne sound insulation performance. The impact, because it's the amount of noise generated by this tapping machine, is a much more abstract thing. It's much harder to really get your head around. An impact level of 58 with the tapping machine corresponds to an audible level of footfall noise, but at a level that is deemed not to be excessively intrusive. So if you're sitting listening, you will hear footfall noise from above. It'll be dull, not particularly loud, and you wouldn't generally, for example, be able to follow someone about the room. Whereas at higher levels of impact noise, when you're sitting, if you hear somebody walking about above you, yeah, you can literally follow them about the room if it's poor performance. So it is audible. You really need to get down into, I suppose, low 40s in terms of that impact noise level before it becomes inaudible or even starts to become inaudible. Well, I suppose it really depends on what way the assigned certifier wants to run it. The test, strictly speaking, I suppose the testing is the only thing that absolutely must be conducted by a competent individual. Having said that, any acoustic design and assessment prior to that, and constructions I would recommend should also be conducted by an acoustician, somebody with the appropriate experience. In truth, the regulations don't go into that aspect of it. They leave the design element out of it. And I suppose one thing you need to be aware of is that a tester, somebody who is a certified tester, is not the same thing as a consultant. Because a tester has demonstrated his or her competence to undertake the measurements in accordance with the standard, get a reliable, repeatable result, analyse it properly and report it properly. That doesn't necessarily mean that they can design sound insulation of a building for you. It also means, I would imagine, we'll get situations arising where a tester comes across a construction and there's a fail, but they won't necessarily be the person to give you the advice on how best to remediate it. At that point, you're going to want to speak to a consultant. I think it's envisaged that it would actually be something like the summary report from CITRI, from the visit website, that would constitute the certificate. Alternatively, for each site there will also be a much more detailed, much more comprehensive report. But at the moment there's no dedicated specific certificate relating to sound testing results. I don't know whether that's something that's the department's even giving any consideration to. There isn't at the moment, but as I say, we've been using either the report or the summary report as the basis for confirming compliance. I think that's the best way of putting it. A step too far at the moment. I think the new mandatory performance requirement and the requirement for mandatory testing is in a lot of ways a huge leap. You know, it's a big change and a very welcome one. So although during the development of the amended Part E, I think it would be fair to say a number of us lobbied for other things like that to be taken into account. I think there was a feeling that, look, we're going far enough now, we'll take it further the next time. You know, I think the sense was really that they wanted to get the new performance requirements and the testing requirements bedded in before they start to look at other aspects of it. For example, I talked about the assessed sound details earlier. This is just another example of the fact that there are a few loose ends that are a little bit unsatisfactory still. The assessed sound details, I mentioned at the end that once you've done your 30 tests on 2 sites by 2 different test bodies, you need to get it certified by a third-party certification body. There's no procedure for that yet. You know, and even though we've asked the question, there's none there. We're hopeful that we might be able to get CITRI, the scheme for testers, to act as a certification body for that. But at the moment, there's no procedure for that. It's usually the builder. It can be the architect, it has been the architect, or an engineering practice, but it's usually the builder. Yeah. Exactly. I'll do that first, because a plasterboard ceiling wouldn't come onto that scale at all. You know, it's very reflective. So it's probably below a Class E, wouldn't even be classified, as an absorber because it's a reflective material. So you're really talking about things like fabric finish acoustic panels, timber acoustic panels, acoustic foams, perforated plasterboard, mineral fiber ceiling tiles. They're all, typically Class D, C, and better. Your first question was in relation to refurbishments and things. There's no, at the moment, the way the regulations are written, it's basically, the aspiration is that everything will be brought up to that same minimum standard of 53 decibels airborne and 58 impact, even a refurbishment. There was some talk at one point of having slightly less onerous performance requirements, but that was eventually dispensed with. So irrespective of whether or not it's a new build or a refurb, theoretically you need to be bringing it all up to that same level of performance. And it should be practicable because it's not an excessively onerous level, to be honest. Having said that, the regulations do contain a little bit of wriggle room, in particular when you're looking at protected structures, for example, and it's acknowledging that it just simply may not be possible to bring the performance up to the same standard in a protected or an old structure. So there's a little bit of wriggle room in there. But in truth, with your careful consideration at an early stage, which is key, you should be able to get up to those levels even with refurbishment. In truth, we had pushed to get the standard increased generally to 56, because 56, Scotland, for example, have gone to 56. But again, to use Cormac's phrase, I think that was just a step too far at the moment. So, but we would expect that performance standard to get pushed up in, for future versions of the regs. Thank you. Unfortunately, I don't think there's a general guide. Manufacturers of specific products, these types of absorptive products tend to produce specification guides and more generic guides to acoustics. So they typically would have a blurb saying, this is what the regulations say, this is how you can go about achieving them. And then, of course, on the last page, and these are the products that we sell that will achieve them. I know what you're looking for, a more generic thing that might point you at different types. Unfortunately, something like that doesn't really exist at the moment. Now, I mean, if there's a tester appointed or consultant appointed who's looking at the design, they'll be able to point you to all of the different products that are available. That's typically what we do if we're engaged in this at the design stage. We'll basically outline the requirements, tell them what is the minimum we have to do, and then offer maybe 5 or 8 or a dozen different material types depending upon what they've said they'd like to use.
Just by way of background, some importance on the significance of is that normally lectures like this cover by the concept of some it's indicative of the importance of the subject matter and this related to these problems. This is something I think a lot of us aside from that, there were some questions that I think that's a measure of the percentage which tonight and roughly the function
Yeah, it wouldn't be 53. You'd be in I'd say we're in the high 40s here in terms of the airborne noise between here and next door. But it's a nice room acoustic environment.